We know that power functions has the form f of x equals a times x to the b. And now the question is, what is the domain? What are the possible domains? Well, let's remember that domain are the values of the function, or what you can plug in and get a number. So domain, what can I plug in, get a number out? In other words, it's where the function is defined. So if I look at, let's look at one example of a power function. If I look at g of x equals x squared, is there any reason I can't plug a number into x squared? Is there any problems? No. So what's the domain of x squared? Domain of x squared is all real numbers. So there are absolutely no issues. Oh, I mean, there are lots of ways that people see it written, and they're all valid. So I love the Blackboard double R, because that's what you'd use in like a 300 level math class. People also write the open interval negative infinity infinity. It's an open interval because infinity and negative infinity are not included. You could also say all real numbers. Any of these say the exact same thing. What about if we look at h of x equals x to the 1/2? Now I'm not getting any y values for negative x. Can't take the square root of a negative number. So this missing part over here where x is less than 0, don't have any outputs for that. So that's not in the domain. So the domain of square root of x, the domain of h of x equals square root of x is x greater than or equal to 0. Or you could also say all non-negative real numbers. So sometimes use non-negative to mean not negative. So that's something else we figured out, or we saw through our exploration here. And then we could look at, well, what's another thing that could happen? Well, I could look at the domain of u of x equals 1 over x squared. And that one's kind of interesting. It looks like I'm getting an answer everywhere, except there's weirdness at x equals 0 because I can't divide by 0. So the domain of 1 over x squared is all real x except for 0. Or you could say in set builder notation, if you're feeling like it, x in the real numbers such that x is not equal to 0. This colon, so you could say x is a real number, x is not 0. This means something is in something else. It's like a backwards E sort of. So those are 3 things we've identified. We've seen an example where it was everything in the real numbers, all real numbers. We've seen an example where it was just non-negative real numbers. Now we've seen an example where it was non-zero real numbers. And then the question is, can you get anything else? And that's where our parameter sweeping comes in. So we're going to try different values of B and see what happens. See if we notice patterns, collect data, right? So I've given you the tools to get started, and now I'm going to ask you to play with it.